We've got 0 or more occurrences of the previous pattern. So that's clean star. So it's different from a glob because it means of the previous pattern. It doesn't mean 0 or more of anything right here. It means 0 or more of whatever the preceding pattern was. Another meta character is dot. It's the same as question mark in a glob. So it means exactly one of any character. So if we see dot star, that means 0 or more of any character. Okay. Next up, we got square bracket, PQR square bracket. So this is a single character that is any one of the characters on the inside. So it's the same as in a glob. So it's going to match a single character and the ones that are listed on the inside. All right, we can do the same thing with a range of characters, and that has issues with locale settings, so it's better if you use the POSIX classes. All right, now here we can negate with the hat or the caret, whatever you prefer to call it. So in a glob, you're supposed to use the exclamation mark, but the hat character also works on a glob. Just is dot is 0 or more of any character, or just one of it. Dot is one of any character. So there has to be one character, but it can be anything. Next guy is if we have hat at the front of a string, that means the start of the string. And correspondingly, a $sign at the end of a pattern means the end of a string. Okay, then we've got all these funny escaped things. So \w means a word character, and a word character is an underscore or an alphanumeric character. Capital W means a non-word character. Hold on, I'm going to turn my mic down a touch. There we go, a non-word character. So basically any character that is not an underscore or alphanumeric. All right, then there is \s. That means a whitespace character. So it's a synonym for the space POSIX class. So the space POSIX class is space, tab, new line, line feed, vertical tab, that kind of stuff. Okay, capital S means a non-space character. So basically not one of the ones I just listed. So that's a synonym for the not space POSIX class. Right, then we've got the confusing ones. So a lower b means a word boundary. So it's the empty string at the edge of a word. And remember, a word is defined to be a contiguous sequence of word characters, but also a contiguous sequence of non-word characters. And a word boundary is a transition from a word character to a non-word character, or vice versa. Where we consider the start of line and end of line to be non-word characters, even though they're not characters. Okay, capital B is a non-word boundary. So it's a position or a location between two characters that is not a word boundary. So we have that complicated definition for a word boundary, and then this guy is just a negation. Right, then we have these two, the less than and the greater than. The less than means the start of a word, and the greater than? Yeah, whatever. Whichever one is which. The greater than means the end of a word. So this /b could be either the start or the end, but these guys are explicitly saying the beginning and the end. All right, then we have this practice. I'll let you review that at your leisure. All right, so those are the basic regular expressions and their meta characters. There's also these extended regular expressions, and they're extended because they're going to add more meta characters. So it's going to add these ones. We'll go through them one at a time. So the first two we're going to look at are plus and question mark. So plus means one or more occurrences of the previous pattern. So it's kind of like clean star, except clean star will take 0 things. The plus requires there to be at least one, because it's pretty common that you might want one of something. So here's our example. B plus will match B, 2 Bs, 3 Bs, 4 Bs, but it doesn't match 0 Bs. So clean star, so if it was B star, would match 0 Bs, but B plus will not. It has to have at least one. So here's an example from a lexer for a C compiler. We have hash mark include, space, plus, and then angle brackets stdio.h. So this is saying there can be any number of spaces, but there has to be at least one. So one or more spaces. So it'll accept these two strings with one space between them, or two spaces between them, or three spaces between them. Any number as long as there's at least one. All right, so we can say 0 or more, and we can say 1 or more. It would be nice to be able to say 0 or 1. So that's what question mark does. Question mark is going to indicate 0 or 1 occurrence of the previous pattern. So for example, b question mark will match the empty string, and it will also match a single b. Right, because if it's 0 or 1 b's, if there's 0 b's, well, it's empty. And if there's 1 b, then, well, there's a b. So before, we had this example Truman where we put a clean star here, and it would match this string with all these extra e's, because that's the best we could do with the tools we had. But now we have question mark. So if I put a question mark right after that e, it means 0 or 1 of those e's. So it'll match Truman with no e, and it'll match Truman with 1 e, but it will not match Truman with 2 or more e's. So here's another example from a lexer. We have the hash mark, which is the preprocessor directive. And then it says space question mark. So there could be 0 or 1 spaces between this hash mark and the include string, but there cannot be 2. There's 2 spaces, then this pattern will reject it. So plus is 1 or more, question mark, 0 or 1. All right, so next we have or and round brackets. So the pipe character here is taken to mean a logical or in a regular expression. So if you read the documentation, it's called alternation, which I think is a terrible name, but basically we have one alternative on the left and one alternative on the right. So there are rules of precedence in regular expressions, and concatenation has higher precedence than the or. So if we put this string, Woodhouse, and we say or woodcock, it means the string or the substring woodhouse or the substring woodcock. It's not the E or the W. It is this whole string or that whole string. And these examples are from your text. I think they're terrible examples, but they're from your text. Sorry, I think they're terrible in they chose to call them woodhouse and woodcock. Not that they're bad examples, just bad words. Round brackets is for grouping sub-expressions together. It works really well with the or. So here's an example. Our previous one was woodhouse or woodcock. Well, they both start with wood. So we could factor the wood out on the left. And now it's wood, and then wood is either followed by house or cock. So here's another one. We've got GRA or E. And you notice, again, this is grouped to say it's either an A or an E. So here we go. These are the 2 spellings of gray. So it'll match either spelling of gray. A more practical example that you might actually write in code, we got an @ and then a grouping that's either samp or code, and then there is a literal open bracket, open curly brace, because curly brace is going to become a meta character in an extended regular expression. Then we've got our, I'm going to copy this because it's really awkward to talk about these in the slide. Okay, so let's grab a new file. There we go. Ugh. Whatevs. Oops, I zoomed too much. All right. Let's go back and back and back and back and back and back. Okay. So we've got a literal @ and then there's a grouping, and it says it's either samp or code. And then we've got a literal open curly brace, and then we've got an unescaped square bracket. So that means this is a single character that is either, well, it's anything except for the 2 curly braces. But that happens 1 or more times. So there is 1 or more characters that are not braces or not curly braces. And that is followed by a literal curly brace. Okay. So that's going to match something like @code with foo in between the braces, or @samp with bar, right? Anything in there that is not a curly brace. But it won't match @code bracket bracket because there has to be one non-curly brace character in between them. One or more of them. That's what the plus says. It will match @code x close curly brace, because remember we're matching substrings. It doesn't have to be the whole string. So this part that's highlighted in green will be the match. So we've got the @code, no problem. That matches the @ and the code. And then I've got a literal open curly brace, yep. And then there's an x. Well, an x is not a curly brace, and it occurs once. So there we go with the x. And then it's followed by a literal closey brace right there. So that's an accept. That one's accepted. It has an extra curly brace on the end of it, but I didn't say that this thing ends with. There's not a $sign there. So I'm allowed to sneak an extra curly brace in on the right. And it's still accepted because it accepted a substring. Okay, and like how this one up here was not accepted, this one down here is also not accepted because that curly brace in between the two brackets, or the two braces, is not allowed to be an acceptance criteria. Right, it says there has to be one character between the two braces that is not a brace. So we can't take it to be this substring, because that does not have a character between those two braces. But we also cannot take it to be this substring because the character that's between the two braces is not allowed. It has to not be that character. All right. Round brackets. So we were already using the round brackets. The round brackets can be used in a basic regular expression, but it's bizarre. You have to escape them to make them into meta characters. So normally we escape something to change it from a meta character to a literal, but in a basic regular expression, if you escape a round bracket, it changes it from a literal into a meta character. Right? That's not the case in extended regular expressions. A round bracket is a meta character in the extended regular expression. So up here, these were examples of extended regular expressions. Because of this bizarreness, I never use round brackets in a basic regular expression. If I need to use a round bracket, I'm going to tell the tool that I am using an extended regular expression. Okay, so some practice with using round brackets and OR. We've got the example Wilco and then either a C or an X and then any number of Ks and any number of S's. So we've used that one before. We also have this one which we just met, wood, which is followed by either house or cock. So if I give it the input string woodcock, well, it's not going to match anything on the left because it doesn't contain Wilco, but it could potentially match on the right. So here we go. We've got wood, that matches wood. And then it's not followed by house, but it is followed by cock. So woodcock is accepted. All right, same argument for woodhouse. Woodhouse is going to be accepted in the same way. So there's our house to complete the woodhouse. All right, next one up is Wilco C woodcock. All right, so let's see if it matches the left. So it's got a Wilco in it, no problem. It's got a Wilco. And then there's a C. Well, it says after Wilco, there must be either a C or an X. Well, it's got a C, so that's accepted so far. And then any number of Ks and any number of S's. Okay, well, there are 0 Ks right there and 0 S's. Clean Star will happily take 0 things. So it is accepted by the left-hand side. So just this substring, Wilco C, is going to be accepted by the left-hand side here. And that's enough to make the string accepted. Right, but it also is followed by woodcock. And that's going to be accepted by the right-hand side, because we already know that's accepted there. So this particular string matches in 2 different ways. The Wilco C matches the left-hand side, and the woodcock matches the right-hand side. Right, so next up, we got Wilco wood. All right, so let's see if it matches the left-hand side. Starts with Wilco, so we're fine up until there. Then that has to be followed by either a C or an X. It's not, it's followed by a W. So the left-hand side rejects. All right, what about the right-hand side? Well, it's got would, so that's good. It matches up to there, but would has to be followed by either house or cock, and it's not. That's end of string. So it's rejected by the right-hand side as well. So both the left and the right will reject it. Therefore, the whole thing rejects it. Okay, next one is Wilco CX. Well, if it matches anything, it's going to be the left. It starts off with Wilco. So we're fine right up to there, and then either a C or an X. Well, where are we? This one? There's our C. And then we've got to see, does it satisfy the clean stars? Well, okay, there are 0 Ks between the C and the X, and there are 0 S's between the C and the X. Okay, so that's accepted. So this part in green, the Wilco C, is the substring that matches the pattern on the left, therefore it is accepted. Okay, what about would COXK? All right, so first question, is it accepted by the left? Definitely not, because it doesn't contain Wilco. Is it accepted by the expression on the right? Well, it does have would, but it is not followed by house or cock. It's followed by this bizarre thing, COXK. So that's rejected by the right. So it's rejected by both the left and the right, therefore the string is rejected. All right, what about this guy? Wilco CXKS. Well, I know this is accepted already because up here, Wilco CX was accepted. So this will be accepted because it contains that same substring. So that one is accepted. All right, what about would COXKS? Well, we kind of went through the argument above, but let's take it. Is it accepted by the left? No, because it doesn't contain Wilco. It has to have Wilco to be accepted by the left. What about the right? Well, we've got would, but that is not followed by either house or cock, so rejected. All right, what about Wilcox? Sure. Well, we got Wilco, so it might be accepted by the left. So let's trace it. We got a Wilco, followed by C. Okay, we had to have either a C or an X, so we're good up to here. And then the pattern says 0 or more Ks and 0 or more S's. Well, there's 1 K, and then there's 1 S. So that matches the pattern on the left. So that is accepted, and the entire string will be taken as a match. All right, what about Wilco X? Well, it starts Wilco, followed by an X, and then it has 0 Ks and 0 S's. So that is accepted, because clean star, again, will take 0 things. All right, what about XXX Wilcox XXX? Let's trace it. What do we got? It contains Wilco, so we're doing okay. Then there's a C. So the character that followed had to either be a C or an X. So we're doing okay. And then 0 or more Ks, there's 1 K. And then 0 or more S's, there are 0 S's. So that is accepted by the left-hand side. Anyone have questions about those? Oh, there's only 2 of you. Jeez, terrible. Okay. So, now I've got some things where I ask you to compare regular expressions. So on an exam or on an assignment, I might give you 2 regular expressions, and the question will be, determine if they are the same or different. If they're the same, describe the language that they both accept. And if they're different, give me a counterexample that will be accepted by one of them, but not by the other one. All right, so let's start. We've got AA. So the language accepted by A contains 2 A's in a row. All right, it's important to say contains. You can't just say 2 A's in a row, because I can sneak other stuff on the left and the right. So there could be anything as long as there are 2 A's in a row in there somewhere. So contains 2 A's in a row is this language. All right, the next guy is AA, A question mark. Okay, so if I was to read this literally, it says 2 A's in a row, and then either an A or not. So it's saying there's either 2 or 3 A's in a row. Okay, well, if there's 3 A's in a row, then there's 2 A's in a row as well. So those 2 are the same language. because any string with two A's in a row will satisfy this second example. So that means all it's really saying is contains two A's in a row. Okay, the next guy here is a question mark A. So there has to be an A, and then there are 0 or 1 A's, and then there has to be an A. So again, that is either 2 or 3 A's in a row. And if there's 3 A's in a row, then there's definitely 2 A's in a row. So this one is also the language contains 2 A's in a row. If I read it exactly as it is, it's going to be contains 2 or 3, but anything that contains 3 contains 2. So it is contains 2 A's in a row. Okay, the next guy, A star. So there are 2 A's in a row, immediately followed by 0 or more A's. Right, so the minimum number of A's in a row is 2, and the maximum is infinity. Well, same is true for this one up here. The minimum number of A's in a row is 2, and the maximum is infinity, because I can throw more A's on the left, and I can throw more A's on the right. So again, all this one is saying is contains 2 A's. Because if there were 10 A's, well, 10 A's has 2 A's in it, so it just contains 2 A's. All right, next one, 0 or more A's and then an A, 0 or more A's and then an A, 0 or more A's. So I've got 0 or many, 1, 0 or many, 1, 0 or many. So maximum number of A's in a row is infinity, minimum number of A's in a row is 2. So it's still just contains 2 A's in a row. Right, next one, AA plus. So what do we got? There's an A right there, and then there is 1 or more A's. So the minimum number of A's in a row is 2, and the maximum is infinity. So it's the same as all the ones that came before it, contains 2 A's in a row. This one's a little trickier, so I'm going to copy this one, and we're going to throw it in the text file. Okay, it says there's a group of A's that happens at least 1 or more times. So the kind of strings that it would generate would be like this. Well, we could have that, 2 A's in a row, or we could have that, 4 A's in a row, or we could have that, 6 or 8 or 10, like that. So it seems like they might be different, because this is only an even number of repeating A's. So what happens if I give it an odd number of A's? AAA, for example. Okay, this pattern will still accept this input, because it will look at it and it'll say, okay, there has to be at least 1 pair of A's. Well, there's your 1 pair of A's right there. And then it says it's done, it matches, it's accepted. Right, this other A, it doesn't matter, because I didn't say that's the end of the string, and I didn't say that's the start of the string. So we can sneak more A's in on the left and on the right. All right, so let's actually give this one as input to grep. Grep is the tool we're going to use for our regular expressions. Okay. All right, let's do this. We're going to do a grep, and I'm going to tell it it's an extended regular expression by saying capital E. And then I'm going to post my pattern, and I've got it in quotes, so the shell doesn't try to glob it, although there are no glob characters in that one. It's just habit. All right, so if I give it a single A, rejected. There has to be at least 2 in a row. If I give it ABA, rejected. There has to be at least 2 in a row. If I give it AA, it's accepted. If I give it AAAA, it is also accepted. If I give it 3 A's, it's still accepted. Because the plus says, okay, I will only take this thing that comes before me once. All right, so there is your 2 A's in a row. That was enough to satisfy the regular expression, so it's accepted. So far, these are all the same. Okay, who's next? We got an A, and then A plus question mark, A. All right, there's a question mark here, so there could be 0 of them. And if there's 0 of them, it's still just 2 A's in a row. Okay, what if there's 1 of them? Well, if there's one of them, there is one or more a's there. Well, okay, so we've still got a run of a's, and any run of a's that's larger than 1 is going to contain 2 a's. So again, all this is saying is contain 2 a's. It's because of the question mark, I can just say, well, this isn't really contributing anything. Okay, the next example is the same deal, but it's flipped. We've got an a and then an a question mark plus a. So this thing that's in the brackets has to happen at least once. It can occur once or many times. But the thing in the brackets has a question mark, which means it could have 0 things. So we have to have an a, and then we could have one or many of 1 or 0 a's, and then there has to be an a. So the minimum number of a's is 2, and the maximum is infinite. And that is the same as every other example we've looked at. So far these are all the same. It just says contains 2 a's. Okay, now I've got a group AA question marked, and then AA plus, and then AA starred. So one of the things I like to do when I'm determining what these patterns are saying is if there's no restrictions on the left and the right, I figure out, is this thing actually contributing anything? The fact that it's a question mark and a star, I know that they're not, because there could be 0 of them. So I can effectively ignore them because there's nothing on the left or the right of them. If there is stuff, then it's a different story. Right, so I could have 0 of these, and I could have 0 of these. So that means all that matters is what's in the middle. And we've already decided that that is the same as everything else. Right, so far these are all the same. Contains 2 a's in a row. So this one, if I was to read it literally, says 0 or 1 pair of a's, 1 or more pair of a's, and then 0 or more pairs of a's. So the minimum is just the 1 in the middle, the 1 pair, and the maximum is infinity, because we'd have 0 or 1, so the maximum from that is 1. And then the maximum from this grouping would be infinity, and the maximum from this grouping would be infinity. So 1 plus infinity is still infinity. So the minimum and the maximum and everything in between is the same. All right, last one from this set, we got dot star AA dot star. That's exactly the same as this one right there. Because this says AA, doesn't say anything about what's on the left and the right, so there can be anything on the left or the right. Whereas this guy down here is explicitly saying there can be anything on the left and there can be anything on the right. But this one already has that, because it doesn't have any restrictions on the left or the right. So that one is still just contains 2 a's in a row. So all of these are the same language, and all they say is contains 2 a's in a row. All right, let's look at the next grouping. Got A star and not A star. So these look very different. In fact, they feel like they should be different. So let's put them in a text editor and talk about them. All right, so A star, well, if I was to translate that into some literal interpretations, that would be 0 or more a's. Okay, what about this one down here? That is 0 or more not a's. So the question is, are these the same or are they different? And you have to remember, when we're talking about regular expressions, we're matching substrings. Unless it has explicitly got something else that makes it not substrings, it's matching substrings. All right, so this one here, the minimal string I can give it is the empty string. This will match the empty string, because the empty string contains 0 a's. Now, the thing is, every string contains the empty string. So if I was to type this nonsense right there, that contains the empty string a whole bunch of times. So let's just look at this one. So this contains the empty string 3 times. There's an empty string right there in front of the u. There's an empty string between the u and the y. And there's an empty string after the y. All right, so this pattern will accept that input string. Right? It looks like it requires an A, but it doesn't require an A because we said there could be 0 of them. And this string, well, there's 0 A's right in front of the U, there's 0 A's between the U and the Y, and there's 0 A's after the Y. So it is accepted by that pattern in 3 different ways. Okay, so, well, by that argument, we can make the same argument for this thing, not A. Okay, good question. So A works for the first one. Yeah, it definitely does, but it doesn't for the second. Let's look at it. So this says there are 0 or more characters that are not an A. Okay, so right there in front of that A, there are 0 characters that are not an A. And right after that A, there are 0 characters that are not an A. So both of these accept this input string, and both of them are going to accept that input string, because there are 0 A's right there, and there are 0 A's right there. So this one will accept the X, and clearly this one will accept the X. But this one here with the A, okay, well this one will definitely accept it, but this one will also accept it because in front of the A, there are 0 not A's. And after the A, there are 0 not A's. So let's run these. Okay, let's run a grep. And we're going to say it's an extended regular expression, and I have to quote it now because the star is a glob character. All right, so let's give it a bunch of junk and an A and a bunch of junk. Okay, it accepts it, no problem. Let's give it just an A. It accepts it. What about if I give it an F? It still accepted it, because in front of the F, there are 0 A's, and the clean star will happily take 0 things. So it's still accepted, right? Because the star doesn't actually require the A to be there. Okay, so let's get out of this one. Let's do the other one. So we're going to do that, and we're going to do that. All right. Okay, type some garbage, and then an A, and then some garbage. It's really going to like that one, because there's a whole bunch of characters that are not A's. Right, what happens if I give it just an X? Well, X is clearly not an A, so it's accepted. What happens if I give it just an A? It accepts it, because in front of the A, there are 0 not A's, and after the A, there are 0 not A's. So the thing is, both of those accept the same language, and that language is accepts everything. Okay, because these will both accept the empty string, and the empty string is contained in every string. So if I give you the string df, there's an empty string in front of the D, there's an empty string between the D and the F, and there's an empty string after the F. So the empty string will appear in every string. So both of those will accept anything because they will accept the empty string. I think I answered your question. All right, next guy is not a question mark. All right, well, not a question mark. What does that say? It says 0 or 1, not A. Well, same argument. We can say, well, there's 0 not A's, and that's the empty string. So it's going to accept everything. So let's try that one. Okay, we're going to change this guy, change the star into a question mark. Let's give it a whole bunch of A's. And it accepted it. Because, well, right in front of that first A, there were 0 characters that are not an A, and that's acceptable, because it says there could be 0 characters that are not an A. It doesn't require not an A. Because of the question mark, there can be 0 of them. So this one will also accept everything. All right, now the next ones, we've got not A and not A+. I can just grab it. There we go. And not A+. So I've got to determine, is this expression on line 6 the same as the expressions on line 1, 2, and 3? Well, this one says, literally, contains 1 not A. Okay, so 0 is not going to work anymore. We can't say that there are 0 of them. So an example, so far we've all had the things that are the same. So the question would be like, determine if these two regular expressions are the same. If they're the same, describe the language accepted by both of them. If they're different, give a counterexample accepted by one and not the other. So our counterexample, you're correct, is the letter A. Right, so these three up here, they will all accept that because they accept the empty string, and there's an empty string there, and there's an empty string there. Right, but this one will not accept it. It says there has to be at least one character that is not an A, and this string does not contain at least one character that's not an A. So the example here would be that if my counterexample is A, I would say it's rejected by A star, but oh no, it's accepted, isn't it? Hold on, I did that backwards. Accepted by A star, but rejected by the not A. Right, now because I've shown a string that is accepted by one of them, but rejected by the other, I know those two languages are not the same. Okay, the next one was not A+. So this, it says, contains one or more not A's. Well, if it contains one or more, then it definitely contains one. So those are the same language, and it contains one not A. Right, you cannot come up with a counterexample from this one, because any string that is accepted by this guy will also be accepted by that guy because it occurred once. And any string that's accepted by this guy will also be accepted by this guy, because if this is one or more of them, then it definitely has at least one of them. So those two are the same language. But they're a different language from these ones, because these guys will accept just a single letter A, whereas these guys will not. And in fact, these guys up here, the first three, will accept the empty string, whereas these two will not accept the empty string. So you could even say the empty string is accepted by A star, but rejected by this one. Okay, but these two, the not A plus and not A, those are the same language. Okay, next two are these funny ones. Let's get rid of that. And we'll do this thing. And we'll get rid of that. And we'll do this thing like that. Okay, the first one's probably easier to understand. It says there's an A, and then a word boundary, and then an A. So remember, a word boundary is a transition from a non-word character to a word character, or vice versa. And we're going to consider the start and end of line to be a non-word character, even though they're not really characters. Right, so if I've got a word character, and then a word boundary, and then another word character, that is impossible. You cannot have that. So remember, the /b is describing the position between the two A's. It's not describing a character. It's talking about the space, the empty string that's between these two characters on the left and the right. So if I have an A and then another A, the space between them cannot be a word boundary because those are both word characters. So this is impossible. So that one, it's going to reject everything. You cannot give it a string that it will accept. Now this one down here, we can make a similar argument. I've got an A, and then some position, and then a hyphen. So that is a transition from a word character to a non-word character, so there must be a word boundary between them. But this thing is saying there's an A, and then there's not a word boundary and a hyphen, which is also impossible. So this one also rejects everything. You cannot come up with a string that this one will accept. Since they both reject everything, though, that means they're the same language. They are the language that rejects everything. Okay. Let's do these ones quickly. We got an A and a dot star and an A. All right, so if I was to read it literally, it's an A, and then anything, and then an A. So it doesn't say anything about the left and the right. So I read this one, and I see it saying contains 2 A's. Not necessarily in a row, just 2 A's. This one over here was contains 2 A's in a row, but this one is just contains 2 A's. And it's important to say contains, because if you said 2 A's, then I don't know if that means only 2 A's. What if it had 3? So contains 2 A's. All right, now this one down here, it says an A, and then any number of not A's, and then an A. So they look different, because this is an A with anything in between it, and an A, whereas this one is an A with anything that is not an A, and an A. So it looks like we might have a problem if we shove A's in between them, because this one would accept, for example, 3 A's in a row. The question is, would this one accept 3 A's in a row? So let's look at it. So we'll write that expression down. So we're starting off with these two. Okay, and then we have this one right here. Oops, square bracket, not A, square bracket, star, and then A. All right, and our proposed counterexample would be 3 A's. 3 A's is definitely going to be accepted by this one, because we've got an A, and then any number of anything, so that could be that third A, and then an A. Okay, now this one says an A, and then any number of not A's, and then an A. But this one will also match this string. All right, so it'll come along and it'll say, all right, there's your first A right there. And then you said, well, any number of not A's? Sure, right there, there are 0 not A's. So that part is satisfied. And then here is your second A right there. And then you didn't say that's the end of the string or anything else, so it's accepted. So let's give that one to grep. We're going to do, again, we don't need extended regular expressions for this one. Right, if I give it 2 A's, no problem. If I give it an A with a bunch of junk and another A and a bunch of junk, no problem. What if I give it 3 A's in a row? And that is exactly what it did. So it says, here's your first A right there. The space in between them has 0 not A's, and then there's your second A. So it's accepted, because I exhausted the full pattern. Okay, and I think that just answered your question. Right, next one. Well, we've just thrown some not A's on the left and the right. So again, this is a case where I'm going to ask myself, do those things on the left and the right actually contribute anything? Okay, so we're going to grab that guy, throw him there, and throw him there. All right, well, we didn't say anything about the left and the right for either of these, so there could be literally anything on the left and the right. But this one is saying there can be any number of not A's. Right, well, there could also be 0 of them, and then we don't say anything about what's on the left of that. So we could sneak more A's on the left. So that doesn't contribute anything. Likewise, this one over here, that one doesn't contribute anything. For the same argument, I could throw some A's on the right over here, and I could also throw not A's on the right. So I could say this one's just going to match nothing, and then I'm down to this, which is exactly the same as this one. So this third example is the same as the 2 that came before it. Okay, what about this guy? Okay, how do you know if dash E, it's a capital E, not a lowercase e. So here it's a capital E. It's basically, are you using any extended regular expression characters? So question mark and plus are both extended regular expression characters. So because I'm using them, I have to have the capital E. If I don't put the capital E, it'll take the question mark as a literal question mark, because it's not a meta character for a basic regular expression. Okay. Let's look at our next example. Here we go. Okay, what have we got? We've got starts with anything, and then an A, and then any number of not A's, and then an A, and then anything ends with. Okay. Well, that is literally the same as this one here. So it's also the same as this one here. So if I do this, I'll just line them up. The inner part is clearly the same. But this one says starts with anything. Well, this one didn't say anything about what it starts with, so it could also start with anything. And it says ends with anything. But this one didn't say anything about what it ends with, so it could also end with anything. So these two are the same. And if those two are the same, that means that this is the same as all of the other ones. So this one is also the same as all of those. Okay, the next one, I'm going to just copy and paste it from here. It looks like we flipped around where the not A's and the dots are. This one is a little harder to justify. So we're going to put a not A there, and this guy becomes a dot, and then this dot becomes a not A there. Okay. So the question is, are they the same or are they different? This allowed anything on the left, and this allowed anything on the right. But it looks like down here we're restricting what can be on the left and the right. We're saying they can't have an A. Right, this one up here restricted what can be in the middle, but this one allows anything to be in the middle. So they feel different. Okay, so I'm going to space these out so they line up. I guess that means this guy has to shift over too. And that one goes there, and then that goes there. And that's for that guy there. Okay, yes, that's better. Okay, goes like that. All right, so you might think these are different, and you can try to come up with a counterexample, but you're not going to be able to. So how do they look different? I'm going to get rid of the spaces actually now because they're confusing me. Well, they look different in that this would allow A's on the left, but this won't. So let's try to throw an A on the left. What if we just had AA originally, which will be accepted by both of them, and I throw an A on the left? All right, so does the first one match it? Definitely. So it'll say, okay, the dot star takes your first A, and then there's literally an A, and then there are 0 not A's right there, and then there's an A, and then this last dot star gets nothing, but it's accepted because it will happily take nothing. All right, does this string accept it? Well, right here we've got 0 or more not A's. Right there, there's 0 not A's. And then we've got our literal A, so actually I'll push this along as it matches. Our literal A matches the literal A. And then I've got a dot star that will happily eat that A in the middle. And then I've got another literal A, and then it's got 0 or more not A's. Yeah, there's 0 not A's right there. So this one also accepts it. All right, so we could work on this a lot and try to think about it, but the trick is to notice this dot star in the middle will eat any extra A's. So though out here, these dot stars on the outside ate all the extra A's, but this one in here will eat all the extra A's. So if I was to give it 5 A's, the dot star in the middle will eat these 3. And it will say, okay, this A right there, that's the most outer one, and this A right there, that's the most outer one. And then the one in the middle will happily eat the extras. Whereas with the patterns up here, this first dot star will eat all the extras. So the first dot star will eat those 3, and then we've got just AA left, and okay, there's your A that matches that A, and then there's 0 not A's right there, and then there's your A that matches that A, and then there are 0 things right there, and that's done. It's a match, it's accepted. So this dot star pushes these A's to be the outermost ones they can be, right? But we still allow extra A's to slip into the middle, right? And this one allows extra A's on the left, and it allows extra A's on the right. Okay, but we could say, well, there can't be A's in between them, so they must be different, but we've already made that argument about why this is the same as that. That was the previous argument we just went through. So these are actually the same as well. Contains two A's. All right, what about this one? We got dot star A, dot star A, dot star A, starts with, ends with. So I'm looking at the left and the right, and it says starts with anything, and then an A, and then anything, and then an A, and then it ends with anything. That's exactly the same as this one again. Right? This one doesn't say anything about what it starts with, and then an A, and then anything, and then an A, and it doesn't say anything about what it ends with. So there could be anything in front of it and anything behind it. So it is literally the same as this one. The very first one is the same as this one. So far, all of these just say contains two A's. All right, next guy, right here. Good, it's all in one line. Oh, it already has the starts with, it's missing the ends with. All right, there are two A's, so it's looking similar so far, but in front of the first A, there can be anything that's not an A, and in between the two A's, there can be anything that's not an A, and then it must end with anything that's not an A. So on all the previous ones, I've been able to sneak extra A's in somewhere. Like I can sneak extra A's in there, I can sneak extra A's in there, I can sneak extra A's in there. This one I can sneak extra A's on either the right or the left because it doesn't say starts with, ends with. Same with this one, they can sneak in on either the left or the right. And this one I can sneak the extra A's into the middle, or on the left or on the right. This one I can't, because every potential spot where I could try to jam another A explicitly says there are no A's there. So at the beginning of the string, there are no A's, or there's anything that's not an A, including nothing. Then there's an A, and then 0 or more not A's, and then an A, and then 0 or more not A's. So how many A's can I have? Well, we have exactly 0 of them here, and then 1, and exactly 0 of them there, and then 1, and exactly 0 of them there. So 0 plus 1 plus 0 plus 1 plus 0 is 2. So this one can only have 2 A's. So if I was to give it 3 A's, it would reject it. Okay, so let's give it 3 A's. 1, 2, 3. All of our previous ones would accept 3 A's. All right, so we'll try to match. So at the beginning, there are 0 or more not A's. Sure, there are 0 not A's right there. So that's fine. Then this A matches that one. And then there are 0 not A's right there. And this one, this A matches that one. And then there are 0 not A's right there. But then I got a problem. This is supposed to be end of string. It's not end of string. I've still got an A left, so it's rejected. It doesn't accept it. So this one is finally different. This one says contains exactly 2 A's. Not 3, not 1, exactly 2. All right, let's look at this guy. We have got the same thing as above, except it's grouped and then clean starred. So let's copy it. Okay, here. Except this whole thing is in a grouping. And then that grouping gets clean starred. Boom. Is it the same as the one above? And if not, give me a counterexample. And if it is, well, we've already described it. This one says contains exactly 2 A's. All right, here's the thing. That's a clean star, which means there could be 0 of these things. So this one on the bottom here on line 4 will accept the empty string. This one up here will not accept the empty string. It has to have 2 A's. This one, if there are any A's, there has to be 2 of them, but we could also take nothing. Right? So that clean star could decide, I'm going to take 0 things, which means all that goes away, which means we accept the empty string. This one does not accept the empty string. So they are different, and the counterexample is the empty string. So here I'd say line 4 accepts, but line 1 rejects. All right, next one. It's the same thing, but we've got a not a star thrown onto the end. Okay, so let's get rid of you and bring you up. And I'm going to have to just paste this down for a moment. We're going to copy this guy, paste him there, and then it's the exact same thing, except we threw contains not a like that. Okay. All right, so are they the same or different? Well, we broke the previous one with the empty string, so does this accept the empty string? That will take the empty string, and then this will also say nothing. So yeah, this one will accept the empty string, because this clean star will take 0 things, and this clean star will also take 0 things. So both of them accept the empty string. So there's our easy chance at disproving it, and it didn't work out. Okay, well, what happens if this pattern occurs exactly once? So I'm going to come down here and say, what happens if it occurred exactly once? We get that thing followed by this thing. All right, so at the end, it's got this going on. So it's got not a 0 or many times, followed by not a 0 or many times. So minimum of 0, maximum of infinity. So 0 plus 0 is still 0, and infinity plus infinity is still infinity. So actually, this expression right here is identical to that expression right there. Okay, so basically, you can extend that line of reasoning to say, well, this thing here, no matter how many times it repeats, will always end with not a star. So putting another not a star after it doesn't change anything, because this first one will eat all the not a characters, and then this one over here will always take none. So these two are the same, because this thing here is not contributing anything. So this is now, we have to describe the language. We know that this expression on the inside says exactly 2 a's, and then if we repeat that 0 or more times, it's saying contains an even number of a's. There could be 0 of them, or 2 of them, or 4 of them, or 6 of them, or 8 of them, but there cannot be an odd number, because to match an a, we have to go inside the round brackets, and if we go inside the round brackets, there has to be 2 of them. So this says contains an even number of a's, and so does this thing, because what have we got? We've got an even number of a's followed by a bunch of junk that's not an a. So that is also an even number of a's. So they both say contains an even number of a's. Right, so if there's no questions about that one, we'll move on to the next one. So I don't like this way of describing it, so let's just look at that one above, as contains an even number of a's. All right, this one right here. So I'm going to write down contains even. Uh-oh, I'm going to have to log back in again. Ugh. Actually, I think I can just refresh it now. Okay. This guy was contains even number of a. So what about this one? All right, well, let's look at this guy repeated. So if I take this first example, and I'll do it under the first example. If I repeat that twice, again, we can see this grouping in here, where we've got not a star, so 0 or more of those, followed by 0 or more of those, and we've already made the argument that that thing right there is the same as if this guy was not there, because it doesn't add anything. And again, the spaces aren't actually there, it's just removing this thing. Right, but you could do that repeatedly. And actually, I removed the wrong one. Hold on. I think we actually removed that one. Okay. All right, so what happens if it repeats 3 times? Let's take a look. I take that and make it occur 3 times. 1, 2, 3. Okay, so we'll get rid of this one. And we'll get rid of this one, because it's also 2 of them in a row. Right, so what have I got now? I've got this pattern repeating. Right, and even if I apply that to the end, I could say, okay, well, let's do this. There we go. Now I have this pattern that repeats, and then with an extra bit on the end. And that's what I'm looking at here. Or sorry, that's what I'm looking at here. Right, that's that repeating pattern. Right there, there it is, there it is, there it is, followed by some not A's. So that's that. So really what I've done is I've taken this expression here. Notice that however many times this repeats, we're always going to have in the middle this not A star is going to be right next to this not A star for every repetition. And we don't need both of them, so we could take one of them out. So let's take this one out, right there. But now my string says it must end in an A. But that's not the same thing as I started with. So to fix that, I'm just going to throw him right there. So now it doesn't have to end in an A. It still can, but it doesn't have to. And that is this expression right below. So what I've really done is I factored this thing out. For line 8, oh, it's supposed to have the $sign there. Sorry. It just didn't get copied when I did the copy paste. So let's go back and look at the slide. On the slide, it does have the $sign there. All right, so that's the same as this one here. Uh-oh. No, that's not where we are. Where are we? Oh no, I made a mistake. Okay, I'll come back and fix the mistake later. All right. So this is factoring out that duplicate to the right. Hold on, let me think this through. Yes, that is not the same as this one. I'll come back to it later. I want to finish working through. Okay, but it is the same as this one. Yes, it is. All right, down here, we're doing the same thing, but we're factoring it to the left. Let's go back to the mistake I made. Up here. So this string right here requires exactly 2 A's. This thing requires an even number of A's, including 0 of them, but it's actually a lot more complicated than that now that I'm looking at it. Because it doesn't accept just the string B. Right, so if I want to match any characters, I have to go inside the round brackets. So I could say this takes the B, but if I go inside the round brackets, there also has to be 2 A's. So if I give it the string B, this one will reject it, but this one will accept it. Because it'll say, okay, I'm not going to go inside the round brackets, but I'll match your B right there. So they're different. That was super tricky. Even though I had the comment there, I didn't notice. Super tricky. All right, let's keep trucking. So this one here, we've just noticed this can be dropped. Because if this, we can take it out. If it occurred once, no problem. This will pick up the slack. If it occurred twice, the one in the middle will be matched by this one, so we don't need it. And the one at the end will be matched by this one, so we don't need it. So we can factor out the back, no problem. All right, and then this one here is the same as the one above because, well, this would take the beginning not A's, and this will take the beginning not A's. And then this one will take the the ending not A's, and this one will take the ending not A's. And then in the middle, this one will take all the ones in the middle, and this one will take all the ones in the middle. So those two are the same. They've just been factored differently, and those are both the same as the one above it. This one is not the same, because if you give it any character, then there must be two A's. Because I'd have to go inside the round bracket to match the B, and if I go inside the round bracket, then there has to be two A's. Oh, that is way too hard. All right, this one down here. So it looks like I've tried to factor out both the front and the back, and that's not going to work. So the reason I was able to take it out either the front or the back is because always in the middle, it would have had one of these A stars. So I'll show you what I mean by that. So let's grab this. Okay. We'll grab that guy, throw him down there. All right, now let's say this thing on the inside repeated twice. Okay, so it would be this, and then this. And it's missing the star at the end. And these are also supposed to be starts with, ends with. I'll just put it back in. Where's the ends with? There we go. That should be star ends with. Whoops, stop that. And then this is also starts with. All right, so this is if the bracket repeated twice. So what do we got? We got not AA, not AA, not AA, not AA. Oh, that's not right. I forgot to add this guy. All right, so I've made so many mistakes now, I'm going to do it again, because too many mistakes and it's no longer convincing. All right, so this inner part repeats twice. 1, 2, and then that is followed by the outer part right there. So this contains exactly 4 A's, and that makes sense. If the inner part which says contains exactly 2 repeated 2 times, then it must be contains exactly 4, and then followed by any number of not A's. All right, so that's if it happened twice. Let's try to make this guy down here accept 4 A's. Okay, so we need a $sign, and then we got that. All right, so it's going to start with, well, hold on, I'll just modify the expression. We'll take this thing, and for the moment, I'm going to take out the inner brackets. All right, so it's going to start with that and end with that. That would be if the brackets repeat 0 times. All right, but what happens if there were 4 A's? Okay, to match the A's, I have to repeat the inner part twice. So boom, boom. But here's the problem right there. No, it'll still match the same number of A's. There's still an even number of A's, but the issue is when the pattern repeats, it does not allow for not A's to be in between them. So up here, every pair of A's was separated by a not A, and down here, it kind of looks like it until we get to the middle. Because what we're going to do is we're going to throw down A, not A, A, but then we have to repeat, so it goes back, and then it's immediately another A. Whereas up here, it's going to throw down not A, not A, A, and then we repeat, and it puts in another not A. So the difference is this guy got taken outside the bracket, so it doesn't repeat. All right, so if that's the case, then I know I can give it the string. I want 4 A's, so let's give it AAB, AA. I believe the first one will accept it, but the second one will reject it. So okay, let's trace it. So we'll take this string right here, put it right there. What do we get? Well, there are 0 not A's there. So, oh, sorry, I'm going to expand this rather than try to trace it the way it is. Boom, boom, and then we're going to have not A right here. Not A, star. Okay. The first one says there are 0 not A's right there. No problem. Then there's an A. Then there are 0 not A's right there. Then there's a B. Sure, B's not an A. Then there's an A, and then there are 0 not A's right there, and there are 0 not A's right there. We're done. That's accepted. So the first one accepts AA, B, AA. And I should have these in there to be clear that it still starts with, ends with. And then, of course, everything is off by 1. Okay, now this one down here, let's try to do it. Okay, we've got 0 not A's right there. So far, so good. Then an A, then 0 A's not right there, and then an A, but then a B, whereas there had to be an A to match this one. I mean, we can try to expand these out, but it doesn't work. This B breaks it. So at this point, there had to be 2 A's in a row, but we had a B there. If we try to do it from the right-hand side, it's going to be the exact same problem. We'll be able to accept the 2 A's on the right, but then there has to be immediately a third A, and there's not. There's a B instead. So that one is rejected. So the counterexample is AABAA, and it's going to be that line 1 accepts it. Accepts, but line 7 rejects. Okay, so those two are not the same language. And this one I did wrong, even though I have the comment there to tell me, be careful. All right, some next ones. We've got an A followed by a non-word character, and an A followed by a word boundary. So are those the same? And if not, give me a counterexample, and if they are, describe the language. Okay. The other one is A/B. So they're not the same. The counterexample is just the letter A. So line 3 will accept that because there's an A at end of line, so that's a word boundary. But line 1 will reject it because there has to be a non-word character after that A, and there's not. There is no character after that A. So this pattern will reject, this one will accept, therefore they are different. Okay, the next one, ABS question mark. So the next guy is going to be A/B/S question mark. So the question mark part, there's either 0 or 1 spaces. So if they're 1 spaces, does it mean anything? Yes, so the /W is definitely case sensitive. So capital W means a non-word character, lowercase w means a word character. So same with the B's and the S's. So what have we got? A/B/S. Is it the same as this guy? Well, if there are 0 S's, then it is literally the same as the one above it. What if there is 1 space character? Well, then we'd have a transition from A to some kind of space character, and all of the space characters are non-word characters. So then there would have to be a word boundary between them. So really what this language up here is saying, A at end of word, and this one down here is also just saying A at end of word. Right, so it could be either a space character or not, but in either case, that's the end of the word. So those two languages are the same. Whereas this one was different because it doesn't accept just the letter A. Doesn't accept new line character, but D does. Yeah, so when we're talking about the input strings, we don't consider the new line character to be a character. So end of string, or sorry, yeah, end of string is the end of word if the last character was a word character. It's very convoluted. So, well, how to describe it? So, a word boundary is a transition between word character and non-word character. And for the purpose of determining word boundaries, end of line or start of line is considered to be a non-word character. But in all other contexts, it doesn't count. So it's only relevant when we're talking about word boundaries. So /W does not accept new line because new line isn't really a character in the string. That's how we indicate the end of the string. But /B does because that is a word boundary. So both of these say A at the end of the word. Right, and I hope you are convinced if I give it just the letter A, that is clearly an A at the end of a word. Right, because the word is the letter A. Okay, but it's not accepted by this one because it says there has to be a non-word character. So that would be accepted by the first one, and also by the third one and the sixth one, but that's not what this says. That just says A and then a word boundary. So 3 and 6 will accept just the letter A, whereas 1 will not, because basically 1 says there has to be at least 2 characters. One of them's an A, and then the one after the A is a non-word character. But this line only has 1 character, so this one cannot accept it. All right, next guy, we've got AB/W question mark. Ugh, you think I'd learn? This doesn't work. ABW question mark, capital W. We can make the exact same argument that we made up here about the space to apply to this one there. It's still just saying A at the end of the word. All right, what about if it was A space? Okay, well, clearly this will accept A space. This will also accept A space. What about A hyphen? Okay, A hyphen, we're just going to say, well, there are 0 spaces there, but between the A and the hyphen, there's still a word boundary. So this one will accept it. And then this one will also clearly accept A hyphen, because it'll take the A, and then this guy will take the hyphen. And clearly there is a word boundary between them. So they're the same language. A at the end of a word. Okay. Are spacing in between words count as an empty string or white space? So spaces between words are space characters. They're not the empty string. They're not the same. Okay, oh, I did it again. Okay. What have we got? We've got an A, and then maybe a non-word character and a word boundary. So the key thing here is that the non-word character, if it exists, has to have a word boundary after it. So can we find a string that will be accepted by this one but not this one? Well, A hyphen, what do we got for A hyphen? All right, so the A matches the A. There's clearly a word boundary between the A and the hyphen, and then the hyphen is a word character. So that is accepted. What about down here? We've got an A followed by a hyphen. Let's try A hyphen hyphen. Okay. An A followed by a non-word character, so that will take me up to the a hyphen, but then there has to be a word boundary, but there's not a word boundary there. The thing is, I didn't have to take that hyphen here. I could have let it be on the outside. So the a matches the a, and then I say that position right there, that contains 0 non-word characters, so we're okay up to that point. And then it's also a word boundary because it's a transition from an a to a hyphen. So a hyphen hyphen is still accepted. What about a single hyphen? That's clearly going to be accepted by this one. A single hyphen, we do the exact same thing. We say the a matches there, and then right there, there are 0 non-word characters, and then that is a word boundary, so that is also accepted. So this is the same. We could just play a trick where we say, even if it's an a followed by a non-word character, whoops, that is a word character, a non-word character, we'll just say, oh, well, we'll just take none of them. Like that. We'll just take none of them, and we'll say that this is the word boundary right there, and then it's accepted. So still, a at the end of a word. Oof. Okay, a s question mark, word boundary. Well, if it's spaces or not, it doesn't matter, because we made this argument up there, but what if it's not spaces? Okay. Oh, I did it again. Oh my goodness. All right. So what if it's a, oops. What if it was a space $sign? So the gap in between those is not a word boundary. That's how I'm trying to break it. All right, but again, we can just look at this and say, there's your a right there. Those two match. And then this spot right there, I'm just going to say there are no spaces there. And then that's a word boundary. So that was all matching, so it accepts. So again, this is still just a at the end of a word. Okay, let's look at what comes next. Oh my goodness, it's madness. Oh, no, this is not going to work. I gotta remember, it's not going to work. Okay, so it's this thing, followed by a word boundary, followed by a word character? No, non-word character. Is that what it is? BW, yes. All right. This is not going to change anything. Like, we were able to do a lot of convoluted arguments to say that it's all going to basically reduce to an a followed by a word boundary. That's what it all comes down to. So I've got to try to change this guy right there into that guy right there. That's easy to do. I just say there's 0 of these, and there's 0 of these. So if I do that, let's take a look. If there's 0 of these things and 0 of those things, then I'm left with that. A followed by word boundary. Well, we're still talking about the same location, so it's just a/b. And I'm allowed to do that because I've got no restrictions on what appears on the right. If there was something else over here, then it would be different. Okay, my brain is getting very tired from these because these are fairly complicated. All right, so far everything has been able to reduce down to a/b. Oh my goodness. All right. All right, what about this? A/b, word character, non-word character maybe, / capital B, non-word character maybe. All right, so what I did last time was I said, well, let's just say that there are 0 of these and 0 of these, but I can't do that this time because this is impossible. You can't have a position that is both a word character and a non-word character. So that's not going to work. Okay, so let's put them back. All right, so we cannot get rid of this non-word character. Can we get rid of this one? No. All right, so let's try this. So a hyphen hyphen is going to be rejected by this string, I think, or this pattern. Let's try it. The a matches the a, and then there is a word boundary there. And then that hyphen is going to match with that w. And then, oh no, it's accepted. No, it's not accepted. Because between the two hyphens, there is, oh no, wait. Let me think. My brain stopped. No, that's accepted. Because that guy right there, between the two hyphens, is not a word boundary. So that is accepted. Okay, let's try a different one. Let's try a hyphen a. Okay, so that didn't work out. The a and the hyphen, that's a word boundary between them. And then this w question mark will take that hyphen. And then the problem is the transition from there to there, it is a word boundary. So that is not the case. So this will reject. Okay, and we can't say, well, then the hyphen's not taken by that, because to do that, you'd have to have the word boundary and the non-word boundary together. So let's try to do it without this one here. Okay, so the a matches the a, and then that's a word boundary, no problem. And then I'm going to say there are 0 non-word characters right there. And then if I'm still at a non-word boundary, which is not the case. Okay, so if I say this matches 0 things, then nothing can match the pattern. If I say it matches 1 thing, then we get to this case here, but then right there is not a word boundary for this string. So a hyphen a is rejected by this. Let's make double sure. I'm going to run it through grep, because this is a really complicated one. We'll do a grep dash e, insert, go, a hyphen a, rejected. Good. Okay, but this guy up here, that will accept a hyphen a, because it'll say there's your a, and then there's your word boundary, and it's done. So in this case, a hyphen a is my counterexample. So it's going to be line 21 accepts, but line 23 rejects. There we go, so they're not the same. Okay, and then we're done those. Oh man, those are exhausting. How are we doing for time? We've got about 20 minutes left. All right, so a lot of those were really hard, I admit, because I did this one wrong, and I even have a note, because I apparently did it wrong before, and I didn't notice the note, so I still did it wrong. And then this one was pretty difficult. So the question that could appear on an assignment or an exam would be, I give you 2 regular expressions, and I will ask you, this will be the question, determine if the following regular expressions are the same or different. If they are the same, describe the language matched by both of them. If they're different, provide a counterexample that is matched by one of them and not the other, and state which it matches and which it rejects. Okay, so extended regular expressions give us one more set of metacharacters, and they're repetitions, so the curly brackets. So back up here, when we were looking at the funny @ sign, I had to escape a curly bracket because a curly bracket is a metacharacter in extended regular expressions. It's not a metacharacter in basic regular expressions. Okay, so it's repetition. All right, so curly brackets. We can have it in 4 different forms, and here they are. If we want to match a precise number of things, then you put the number in the curly brackets. But remember, when we're talking about precise, we're still matching substrings. So unless you put restrictions on what occurs on the left and the right, you can sneak more of whatever that thing is. And that's actually what this first example shows. So here it says there are exactly 2 A's. Okay, so it's definitely going to match the string candy with 2 A's. But it's also going to match the string candy with 3 A's because, well, there's 2 A's right there. There are exactly 2 A's right there. So that's accepted. Okay, but this one down here where I put a restriction on the left and the right, there has to be a C on the left and there has to be an N on the right. Well, it's still going to match candy with 2 A's, but it's no longer going to match candy with 3 A's. So it'll start matching at the C. It says, yeah, the C's fine. There's your 2 A's, but then it had to be immediately followed by an N. That A right there is not an N, so it's rejected. All right, next up, we've got m, comma, n. So the first one is the minimum, and the second one is the maximum. Again, with the caveat, you have to restrict what's on the left or the right if you want it to really be the maximum. Okay, so here's that example. A, 1 to 3 times. So it'll match candy with 1, candy with 2, candy with 3, but it also accepts candy with 4 A's because there's your exactly 3 A's right there. It contains exactly 3 A's. Or sorry, it contains 3 A's in a row. And again, if I want to really mean at most 3, I have to put restrictions on the left and the right. So we've got candy, candy, candy with 1, 2, and 3, but not 4, because we've got our C and then our 3 A's, but those 3 A's had to be followed by an N, and that 4th A is not an N, so it's rejected. To do a minimum, you say the number and then a comma. So here it is, A2 comma. There are at least 2 A's. So here we go. There are our 2 A's right there. Here is more than 2 A's, but that has at least 2. And there's 4, so that has at least 2. But candy with 1 A is rejected because it doesn't have 2 A's in a row. Oh yeah, these are in a row, always. Okay. If I put restrictions on the left and the right, this does not restrict the maximum number, so these will all still match 2, 3, and 4, but not 1, because 1 isn't at least 2. If you want to specify a maximum, again, with the caveat that you have to restrict the left and the right if you really want it to be the maximum, otherwise more of them can sneak in on the left and the right. There's 2 notations for it. You can do comma and the number, or you can say 0, comma and the number. So if I say A 0, 2, this says there are 0, 1, or 2 A's in a row. So it'll match candy without an A. It'll match candy with 1 A. It'll match candy with 2 A's. It'll also match candy with 3 A's because there's your 2 A's right there, and you didn't say there cannot be another A before or after. So this extra A is able to sneak in on the right. Okay, the last one is the same as above, except I've restricted the left and the right. It has to be immediately preceded by a C, and it has to be immediately followed by an N. All right, so we're going to match candy with 0 A's because we are allowing 0. We're going to match candy with 1 A because 1 is between 0 and 2. We're going to match candy with 2 A's because, well, there's 2 A's right there. But we're not going to match candy with 3 A's, so it'll start at the C, and then it'll say, okay, there's your 2 A's, everything's great, but it's supposed to be followed by an N, and again, that A right there, the 3rd A, is not an N, so it rejects. Any questions about repetition? Okay, I'll assume no. If you're typing, I will see it. All right, you can also use the curly brackets in a basic regular expression, just like the round ones, but you have to escape them to turn them into meta characters, which is absolutely bizarre, so try to avoid doing it. Just use an extended regular expression. So the summary for EREs, you have the same things. Can we have more than one match, count, or repetition? Yeah, absolutely. So how would you like it to appear? So I'm not sure exactly what you mean, but the answer is definitely yes. Uh-oh, what happened there? Looks like I popped out of my browser. All right, give me an example, and we'll work it out. Let's do grep -e All right, so let's say we wanted 20 A's in a row. So we have A, and we could do this. A, and actually I don't want to type 20 of them. Let's say there are 4 of them. Let's do 6. 6 A's in a row. Okay, well, we got 1, 2, oh, I mistyped grep. All right, 1, 2, 3, 4, 5, 6. There we go. There is 6 A's in a row. Everything's great. And it's also going to accept more, right? Because that contains 6. 1, 2, 3, 4, 5 gets rejected. All right. Another way we could have done that is we could have said there's 2 A's in a row repeated 3 times. I hope this works. Yeah, great. Okay, now let's try this. So there's my 6, and let's add 2 more, and it matches exactly the same way. So there's your 6. Right? It won't take 3 because it's 3 groups of 2. It won't take 2 because there has to be 3 groups of 2. But it will take 6 of them. Yeah, you can totally do that. So A6, B3, that's a little long. Let's do A2 and B2. I guess we could have done 3. It's not that bad. So that's 2 A's in a row immediately followed by 2 B's in a row. Right? But they do have to be right next to each other. If you've got AXA and then BB, that's not good enough because this says there is an A repeated twice, nothing in between it. Right? And if you had AAXBB, that's also rejected because the B has to immediately follow the A's. Okay, and you can even do groups. So let's do a group. Okay, let's say we've got A happens twice, which happens twice, followed by B2. So we got 1, 2, 3, 4, BB. That's accepted. If I just do 2 A's, BB, that's rejected because it has to be 2 of whatever is in the round brackets. Or let's make it more interesting. Let's make this guy AC repeats twice and then B twice. So AC, AC, BB. That's the minimum that will be accepted. If I do AACC, BB, that's rejected because that's not AC repeated twice. Let's try CACA, BB, rejected. Oh, I can't do up arrow, sorry. CACAC, BB is accepted because there's my AC repeated twice followed by BB. Spacing does make a difference because your regular expression is in quotes. So if you put a space in somewhere, it literally means a space. So example would be, let's do an A and then a space, and then let's say 3 to 6 space, or sorry, 3 to 6 and then a B. Okay, whoops, I forgot to say grep. Grep dash E. Right, so now we've got an A, and then there's 1, 2, 3 spaces and a B. That's accepted, and up arrow doesn't work. All right, let's try an A, 1, 2, 3, 4, 5, 6, and then a B. Great, let's do an A, 1, 2, 3, 4, 5, 6, 7, and then a B, rejected, because there can be at most 6 spaces there. Let's do an A with 2 spaces, also rejected. So space means literally space character. So spacing does matter, yes. All right. Oh, I think what you were actually asking, though, was what if we had A2 space B2? That is a different language, because previously AABB would be accepted, but now it's rejected because there has to be a space between the 2 A's and the 2 B's. Yeah, I think that's what I just did. Not square brackets, curly brackets. Square brackets are the character class, right? So if it was square brackets, it means something else. If we did this, right? That is an A followed by a single character that is a 2, followed by a space, followed by a B, followed by a single character that is a 2. So if I did AA space BB, which would be accepted by this guy here, this one's going to reject it, because what it wants is an A, a 2, and a B and a 2. So the brackets mean different things, and unfortunately you got 3 kinds of brackets to remember. You got the square brackets, which is a single character that's one of the things inside of it. You got the round brackets, which are groupings, and now you got curly brackets, which is repetition. So 3 kinds of brackets, 3 different meanings. All right, so we did summary. All right, so there's some examples. I should probably cover this. We've got 5 minutes. We got something that's an H or a C 1 or more times, followed by AT. So we've got hat and cat. That's going to work out because there's 1 H or C. 2 H's is going to work out because the plus just takes 2 H's, but also chat. So when you got this plus, it doesn't have to be the same character. It just has to match that pattern. So the C is one occurrence of matching the square brackets, and then the H is a second occurrence of matching the square brackets, and then AT. Same deal for this one, and then this one, same kind of thing. We've got a C, an H, a C, an H. Those all match the square brackets, so the plus takes them all, followed by AT. Right? HC question mark AT. Well, it's going to match hat because there's 1 H. It's going to match cat because there's 1 C. But it also matches at because the question mark will take 0 things. And because of that, it will match bat as well. Because when it looks at bat, it's going to say, okay, right there in front of the A, there are 0 H's or C's. So the question mark is satisfied because there were 0 of them. And then AT. So bat will still be accepted. So HC star AT, it's similar to both of these combined. It matches hat and cat and double HAT and chat and HCAT and also CCH CHAT. But because it's clean star, it also matches at, because it will say, all right there in front of the A, there are 0 H's or C's. So clean star is happy with 0. And then there's your literal AT. But because it matches at, it will also match bat, because it will say right there between the B and the A, there are 0 H's. And then clean star will be happy, and the square brackets will be happy. Right, because the square brackets want either an H or a C, so I'm just going to say without loss of generality, we'll talk about H's. And clean star will say there are 0 H's right there, and clean star is happy to take 0 things. So that means it'll also match bat. All right, so cat or dog. Well, that's going to match cat or dog. It's also going to match cats, because there's cat as a substring. I didn't say starts with, ends with, and I didn't restrict what's on the left or the right, so I can sneak an S in on the right, no problem. Also dogs, because I can sneak an S in on the right of the dog. Also my favorite palindrome, taco cat. So there's my cat, and I snuck taco in on the left, because I didn't restrict what's on the left. And who's listening? Just 3 of you? Well, if any of you are Korean, we could also have time dog, which is their word for clock, shige, which literally translates to time dog, which I think is hilarious. All right, then there's some practice. I think I'll leave these to you. And if you want to know more about regular expressions, here's some links. These first 3 are references. They're pretty good references. They're the ones I always go to if I need it. And the next 3 are little interactive things that you can use. So I'll just go to the first one, regexpal. And you can give it a test string of whatever you want. Right, and then you can give it a regular expression. So let's say I want to find all of the word boundaries. Yeah, it doesn't like that because they're not visible. Okay, let's say I want to find all of the occurrence of JS. So there's 2 of them in a row right there. or all of the occurrences of Ks followed by word characters. There they are. Let's do a more interesting one. Let's say we're looking for, yeah, Ks followed by word characters. So there's all the Ks. Note this one right there at the end of that word, IFUK. We'll throw, it has to be followed by a word character, but now we lost this one because that's not followed by a word character. That is followed by a non-word character. So let's change it. There it is. We got our K followed by a non-word character. Or we could say K at a non-word boundary, those two. Or we could say K at a word boundary, that one. All right, so this is more interactive and quicker than using command line. But command line, you have more control, because I don't think you can tell this one. Oh yeah, you can select up here which version of regular expressions it is, but neither of those are the ones that we're talking about. So we're talking about the GNU grep version of regular expressions. They're fairly close, but they're not identical. And that's the end. Would it work if I tried grep-e, doodly-do, an A to Z, B, 22, and then AAX? Well, no, because you said 22. I think you meant to say 2. So let me grab this thing. Hold on, but I think that may have been a typo. All right, so I'm going to take what you literally said first, and then I'll correct your typo. All right, so will it work with this thing? So basically, does it accept or reject? Well, if you got that question, type it in and see, but we can trace it. There is definitely not 22 Bs at the end, so that is rejected. All right, so what if it was 2 Bs? Well, what have we got? So if you didn't catch the first lecture, this thing is modeled, we can think about this thing as a non-deterministic finite automata. And the difference between a non-deterministic finite automata and a deterministic finite automata is that you can either think of the non-deterministic machine in one of two ways. It either makes every choice, so whenever there's a decision to make, it will make every choice, or you can think of it as it always makes the right choice. I prefer to think of it as the last one. So if I look at this input string, and I've got decisions to make, like, is this the first A right there, or not? Because it could be that one, or it might be that one, or it might be that one. Right? If I choose this one, that's wrong, because that A is not followed by another A, so it's rejected. If I choose this one, maybe it'll work out. Let's find out. So we got an A, followed by an A, followed by an A, so we've consumed the pattern up to there. But then there had to be a B, so that was also the wrong choice. Okay, but now let's choose the one in the middle. So if I choose to start my match here, this is the first A, that's the second A, so we're matched up to there. Then there's an X, that matches those square brackets. And then there are 2 Bs, which matches those 2 Bs, and now I've consumed my entire pattern, so that's a match. And then let's try typing it out down here. Okay, my input string is 1, 2, 3 A's, and then an X, and then a BB. And it's accepted. Exactly the way that I said it would be. It chose this to be the starting point for the match. Right, so I think that's where I want to stop today. There are a couple of practice things on the slide that we skipped over. So you can look at these and work through how they match, but they are all highlighted. And then there is the quiz on D2L that you can work through. And tomorrow,